I'm going to go over a couple of questions from our week one reflection. The first thing, I had a couple of you asked about just strings in general, right, and how we're working with them. So the idea here is that before when we define a set, we called it a collection of objects, but usually those objects were all numbers. But now here, what we are introducing is that maybe sometimes it is not full of numbers, and instead in this case it's full of characters, right? The characters being A, B, C. Okay, and if we say that a set of string over A, let's say sets strings of length 3, right, then we could have A, B, C, right? Or any kind of combination or any ordering of A, B, and C. Or we can also have, again, they just have to come from that set. We can use them as much as we want. We could have something like that, right? And these would be, so these here are characters. And these are strings over the set A. Okay. All right. So let's take a look. We had a couple of homework questions here. Okay, so here it says let T be the set that consists of the two characters X and Y. List all strings of length 5 over T that have exactly one Y. Okay, so then that means here 1, 2, 3, 4, 5, right? Of length 5, right, that have exactly one Y. So we can think, all right, one Y, and that means that there are only two options. So the rest would have to be X, right? So that's an example of one, but now just looking at this, we could see, all right, well, what I can do is I can do that. All right, and then I can keep on going where I just move it, so forth. The Y would be in the third spot. Okay, and then I can continue this till I get the Y to be in the last spot, and that would give me 5 different sets of strings. Okay, so that's how you would approach that. Okay, so I had a question on number 12. So it states, let A be the set containing the two characters, X and Y, and let S be the set of all strings over A, right? So no length kind of associated with it, just any string that consists of X's and Y's. And it says define a relation C from S to S, so between the two sets, for all strings S and T in S. Okay, so a couple things here. We can see here using some kind of set notation, right? X is an element of A and Y is an element of A. Right? Now, if I have a string where I have more than one character, this is not an element of A, but it is an element of S. All right, because it's a string, right? So the set S would involve any kind of strings, etc. Right? Of any length, as long as they contain only X's and Y. So then it states, the next part, it states, then C is a function because every string in S consists entirely of X's and Y's. And adding an additional Y to the left creates a single new string that consists solely of X's and Y's, also in S. Okay? All right. So it says find C of X. Okay? All right. So C of X would be looking at the definition we have here, would just be YX. Right, so we just put a Y to the left of the string. And then C of YY, what do we have here? XYX that would be y, 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 x, y, x. Okay, so that's how you approach that problem there. Okay, and another question I got here was regarding problem number 20, where it says define functions h and k from R to R by the following formulas. For every x in R, h of x equal to x minus 2 squared, and k of x equals to x minus 1, x minus 3, that quantity multiplied by each other, plus 1. Does h equal to k? All right, now in order for this to be true, h equals to k if and only if h of x equals to k of x. All right, and that would be for all x. Element of R, the real numbers. Okay, so one thing we can do is we can expand to show that it is actually the same function. Right, so we could say, all right, h of x is equal to x squared minus 4x plus 4. All right, and then k of x would be, so we get x squared minus 4x plus 3 plus 1, and that gives me x squared minus 4x plus 4. Okay, giving us here the same function. So then that implies that h must equal to k. Okay. All right. Thank you.